This is a presentation about past extent of lunar permanently shadowed areas. I'm Norbert Schorghofer, and this work is in collaboration with Schorghofer Rufu. Now, one can argue that permanently should be replaced with perennially, because the PSRs with permanently shadowed regions aren't really permanent. I think permanently is okay because it's mainly a contrast to shorter time scales. But the essence of this presentation will be that the PSRs aren't actually that old. Now, there's a remarkable paper by William Ward in 1975, and where he realized that the spin orientation, axis orientation of the moon must have undergone a major change as it moved away from Earth. So it formed close to Earth, and now it's about at 60 Earth radii from Earth. And it started, its spin orientation was first dominated by the tides from your plate Earth, while now it is dominated more by the Sun. And so at some distance, and that's about 34 Earth radii, it must have changed from one Cassini state to another. So a Cassini state is a special tidally locked state, which a moon falls into probably within 100,000 years, very, very short time period. And so at the Cassini state transition, it probably reached an axis tilt as high as 77 degrees, which means that the pole of the moon was close to its orbital plane. And all water ice deposits, which might have been there at the time, must have been lost. Now, the time of this Cassini transition was quite uncertain. And so that has many, led to believe that, Cassini state transition was in deep time, therefore we don't have to worry about it. But, consider it takes a while after the Cassini state transition until the axis orientation is similar to what it is today, and that brings it into a much more recent time period. Now, there has been a wonderful paper last year by Fahard et al. 2022, where they come up with a consistent solution to the Earth-Moon distance as a function of time, and this builds on progress into paleo records for the length of Earth's day, which is determined by or related to similar forces, and geophysical models and so on. And so now we have much more certainty of what the Earth-Moon distance is a function of time. And I drew on top of their data here the 34 Earth radii where the Cassini state transition happened. And what we did then is, assume it's in Cassini state 2, which it certainly is now. We know what the obliquity is. So obliquity is angle between the moon orbit and its spin axis. The inclination of the orbit is relative to Earth's orbit. And the difference between these two is the maximum height of the Sun at the pole, so the maximum solar declination over maximum over a year or so. And that's currently 1.5 degrees, right? And 1.5 degree and 5.1 degree don't quite add up to 6.7. Let's round off, so the obliquity is really a little less than 6.7 degrees, and the maximum solar declination is really a bit more than 1.5 degrees and so on. But now you already see that the solar declination was twice as high, 3 degrees, just 2.1 billion years ago. Right? And therefore the PSR area at the time must have been about half of what it is now. Now here's a map of PSRs for various solar declinations in a south polar region of the moon, and the legend here associates these declinations with times. And this was done, well, first it was done obviously with present-day topography, LoLa topography, and I used a program here posted on GitHub, which I was using for a different project, and that program is really made for very fast terrain radiance calculations, temperature calculations, but here I'm just using the shadow part, which is sort of a side component of that model. And well, you see, some PSRs are much older than others. Here is a total PSR area as a function of time. And I only use PSR at pole of 80-degree latitude. There are many PSRs equator of 80-degree latitude, but they're often not cold traps anymore because of Terray irradiance, right? Cold traps are defined by temperature, PSRs are defined by shadows. But pole of 80 latitude, there's a closest association between PSRs and cold traps. And you see here the PSR area is about half as large, 2.1 or 2.2 billion years ago. And beyond 3.4 billion years, the PSR, they are still in PSR, but they're negligible in size, and they're probably not cold traps, but they basically disappear because the moon moves fairly fast at this time. Now, if one averages this plot with the two axes flipped, one gets the average age of a PSRs of 1.8 billion years, assuming current topography. So if all the craters were already there, the average age is 1.8 billion years. And it's quite possible that the cold traps disappear or emerge later than the PSRs did, and therefore even younger. Now, a point of special interest is Cabeus crater and the LCROSS impact site, because we know there are volatiles at this location. And so here are contours for various solar declinations, 1.5 degree, 2 degree, 2.5 degree, 3 degree. The LCROSS impact site became a PSR at a solar declination of about 2.2 degrees, which is 0.9 billion years ago. So that means the volatiles observed must have arrived there in the last billion years, within a Copernican period, because it only became, that location only became a PSRs, and therefore couldn't have been a cold trap before that at this time. Now, what does all this mean? Well, so the major sources of water on the moon, are early sources and ancient sources. And so outgassing, outgassing continued into, was thought to continue certainly to about 2 billion years ago, so it overlaps with the old PSRs. But certainly most PSRs were not around by the time all these sources are present. And the ice, which is in the PSRs now, has nothing to do, a little to do with the very early sources of water. Now, we also thought about uncertainties and all these angles and timing, and the short answer is that within the last 3 billion years, I mean, these uncertainties obviously become larger and larger. The third one goes back in time, but in the last 3 billion years, they seem to be small. Now, the concept of realization that most PSRs are actually quite young is not new at all. Arnold wrote about it in 1979, which was, after the paper by Ward. But now I think it's just far more certain that the PSRs aren't that old. So conclusions: the average age of PSRs with current topography and poleward of 80 latitude is 1.8 billion years. Most PSRs are younger than 2.2 billion years, and the PSR area becomes very small beyond 3.4 billion years ago. That means most of these PSRs weren't around when these ancient sources of water were present, and therefore there couldn't be that much water in the cold traps. But on the other hand, the LCROSS impact site has volatiles and is a young PSRs. So this also suggests that even the young PSRs are expected to have some water ice and volatiles in them, just not as much as the older PSRs. And I have posted the maps of past PSRs for the North and South Polar region at this link shown at the bottom of the slide.